Hi, my name is Ashley Voltz with Informa. I'm here at Bioprocess International in Boston, Massachusetts. And today I'm speaking with Mike Johns, Senior Scientist at MilliporeSigma, about their new CHO cell line. Thanks for speaking with me today.
You're welcome. It's nice to be here.
So let's get right into it. What are some root problems in the CHO cell line development that contribute to long timelines and limited throughput?
There's a lot of problems facing the industry today. One of the primary ones is that CHO cell line development takes a really long time. It can take 3 months to 6 months or even longer to develop industrially relevant clones. So when you're spending that much time making a CHO clone being used for our therapeutic production, there's a lot of risk involved that you might have to redo this process or you're not going to get the clones that you need.
Interesting. And how does CHOZN Elite cell line address some of those issues?
So CHOZN Elite is phenotypically adapted to be better than normal CHO hosts at our protein production. So by phenotypically better, I mean it tends to yield clones of higher productivity, of more stable growth profiles and protein characteristics. So really, when a customer is using CHOZN Elite, they're going to have more clones that are going to be industrially relevant at the end of their process, which minimizes the risk.
There's 6 characteristics about the CHOZN Elite that we think make it a great host for bioproduction. First, we're able to get clones of much higher productivity than we normally get with CHOZN GS. So far, we've been getting titers anywhere from 7 to 13 grams per liter in spin tube fed batches. And this, I want to stress that this is without transposases or TI and without a lot of high throughput equipment or robots. We hand jam these clones. We're doing limiting dilution and analyzing maybe 200 to 250 clones from the static stage. Second, we think that this cell line should be easy to adopt, particularly by people who already have licenses with CHOZN GS. The cell line was designed to be plug and play with established CLD processes, and it can be used for fed batch and perfusion both, with options for different timelines also. So far, it's demonstrating consistent and predictable growth profiles. So these clones that come out of these cell line development projects, they have predictable growth. They tend to die out at the same day of a fed batch. They act very similarly to each other, and we think that could ease process development. Fourth, the clones coming out of these projects so far have shown high stability. So 85% of the fed batch clones coming out of both mini pool and bulk pool processes are retaining 70% of their titer after 60 population doublings. Right now, we tell our customers and industry, CHOZN GS, you can expect about 80% of your clones being stable. So CHOZN Elite is maybe doing a little bit better than CHOZN GS even on that front. The final 2 points, CHOZN Elite was CGMP banked by BioReliance and passed all advantageous agent testing, so that should ease any regulatory concerns that customers might have. And also, CHOZN Elite is fully traceable from the CHOZN GS cell line. It's derived directly from the CHOZN GS host.
What other CLD workflows is the CHOZN Elite cell line compatible with?
So there's a few workflows that CHOZN Elite's compatible with. One is a tried and true mini pool cell line development method, and that's a longer process. It takes 6 months or so to arrive at clones that are relevant for industry, but generally that process yields clones that are highly productive, so they're making a lot of recombinant protein. Another method is the bulk pool cloning method. So this is a much shorter process, so this takes about 3 months, half the time, but it's at the cost of some of that R protein production. So a customer might want to use this process when they need a lot of different clones, maybe expressing different recombinant proteins, and they can arrive to some of their early material faster.
So to summarize the bulk pool work, the fed batch work, here's the IgG data side by side. So the mini pool process took less than 220 days. It's a long time. but we got clones over greater than 10 grams per liter, which is much higher than what we would see in CHOZN GS. And there's also the bulk pool. Didn't quite reach those titers, but we had a lot of impressive titers nonetheless, and those were all generated in less than 90 days in comparison. Stability was good and acceptable on both of them. So right now it seems like there's a choice that a future customer might have, and that is, do you have a molecule maybe ready for clinical? Do you want to get a clone expressing as much as it can? You might still do the mini pool process. However, if you're preclinical, you have a lot of different molecules you want to evaluate, or maybe you want scientists to be able to perform work in parallel. Maybe you do the bulk pool cell line development. And this data here, it's already outdated. All of our R&D projects going on right now in St. Louis are all using the new bulk pool method. So as of Friday, right before this conference, we're evaluating another set of clones. We identified clones that were reaching 7 and 8 grams per liter. So we're continuing to modify the process. It's a little bit new to us. So I think what we're showing here is the ceiling and not really the limit of what Elite can do. Once processes are more optimized, if we're also testing transposases. If we apply a transposase to this cell line development, would we get even higher clones? Would we reach that coveted 100% stability? We don't know, but we're trying to push these higher and higher.
And with so many recent enhancements in cell line development, what differentiates the CHOZN Elite cell line from other commercially available CHO hosts?
Well, I touched on this a minute ago, but the key differentiator is that it's phenotypically adapted for recombinant protein production. In order to make a host that does that, we took our original CHOZN GS host platform and we performed multiple cell line development and cell line engineering stages in which we finally arrived at a new host that was phenotypically desirable as a recombinant protein producer. And that is what eventually became CHOZN Elite.
I'm not going to go into all the details how we made the cell line. It's not an industry secret. We're calling it a phenotypically adapted cell line, CHO line. So what we did essentially was take CHOZN GS host, and we transfected with a standard MAB, and we did cell line development through the mini pool process. We isolated the top expressing clones that came out of that process, verified for single copy number, and checked other phenotypes that were of interest to us. Once we took the top expressing clones, we removed the benchmark gene fully, and what we're left with are a bunch of CHOZN Elite candidates, we were calling them. So these were clones that showed and demonstrated that they could be industrially relevant through fed batch assays. But they're no longer expressing any genes. So now we have a lot of different clones expressing nothing, no R proteins anyway, and we had to retest them to see what kind of clones we can get out of them through a second cell line development project. So we took all the top candidates, and this is really part of the project that took forever, I think, because we didn't have a whole lot to go off of. We took all the top clones, did a new mini pool cell line development project with a different recombinant protein, and the candidates that had the best performing clones come out of that second project became what's known as CHOZN Elite. So far, we have tested 3 different cell line development paths with CHOZN Elite. So we put Elite head-to-head against CHOZN GS with the mini pool method. That's how most people, or not most, I don't know, a lot of people using CHOZN GS are using mini pools. It's a slower timeline, but it's a way to enrich for higher clones in the end. And we tested that against CHOZN GS in a side-by-side comparison. The second cell line path is through bulk pools. So it's a much faster timeline development or cell line development, but maybe at the cost of productivity in the end. You're not getting that initial enrichment stage from the mini pools. Third is a new cell line development path that a couple of my colleagues have worked on, one of them here today, and that's a perfusion cell line development path. And the difference is, so in the past, we tend to create clones for fed batch. We isolate the top clones, and we see whether they're suitable for perfusion or not. So we thought maybe we can pick perfusion clones. For anyone who's interested in the perfusion process, can we identify those up front and scale up ones that are suitable for perfusion? Looks like you can. I'm going to show you some of that data too.
Now, if people want to get a hold of you to learn more about this, how can they reach you?
At the end of the video, there should be a QR code that you can scan with your camera, and it should lead you to a page, should get some contact information.
Great. It's been really nice talking with you today.
Thank you very much.
Thank you.